lots of different codes and ciphers. The difference between codes and ciphers is codes are one thing, person, idea, or place that is represented by a group of symbols, numbers, or pictures. A cipher is a single letter or number represented by another single letter, number, or symbol. Listen as we explain many of them. We will begin with the one that I helped research, the semaphore alphabet.
Classic alphabet of the semaphore alphabet. It was invented in 1792 in France. But still, how does it work? Well, by waving a pair of handheld flags from a distance in a particular pattern. So here is an example of the semaphore. As you can see, there's a little character, and then here is the alphabet. As well, in finishing this last paragraph, you can try to solve this if you would like. What are the strengths and weaknesses? A strength is it helps people who are flying planes. A weakness is it does not help people who are blind. And those are some facts about the semaphore alphabet. And the solution is Bonner Braves. BONNERBRAVES.
It's Emma
and Riker,
and we have two ciphers today. First cipher is the Pigpen cipher, also known as the tic-tac-toe cipher, Masonic cipher, Freeman cipher, and Napoleon cipher. Heinrich Cornelius Agrippa was the person who created the Pigpen cipher. The cipher doesn't substitute one letter for another, rather it substitutes each letter for a symbol. The alphabet is written in the grid shown, and then each letter is enciphered by replacing it with a symbol that corresponds to the portion of the Pigpen grid that contains the letter. It also has crosses and dots to help you tell the letter or word you are trying to say or discover or understand. The use of the symbols instead of letters does not help as a strength, and this system is identical to that of other simple monoalphabetic substitution schemes. Due to the simplicity of the cipher, it is often included in children's books on ciphers and secret writing. Now we're going to decode a cipher. When decoding a cipher, you have to use the key. So, in this case, the arrow that's upside down is the S. The backwards L is A. And then, so you just keep it.
is the Rosicrucian cipher. It is much like the Pigpen cipher, but uses more dots and not the so-called arrows in the Pigpen cipher. This is my code here. If we solve it up at the top, this line, so it has to be either an A, B, or C. Then we pay attention to the dot. The dot is in the middle, so this would have to be a B. Then square, O, square, middle, N. They're the same, so they have to be the same letter.
In 1836, Morse code was invented by Samuel Morse to help people communicate with other people, like texting in a way.
Here's how it works. Someone types some dots, long and short. You would send this paper to the telegraph and beeps would come out of it like words.
Here's an example of printed Morse code, and along with other international codes, such as the NATO alphabet, which is words for letters, and the international code of flags.
Here is Bonner Braves in Morse code.
Pig Latin was developed in 1869 in May. It works like this. Move the consonant or cluster from the start of the word to the end. Then add a suffix ay to the end of the word. This is how you say Bonner Braves in Pig Latin.
Anabe Avesbray.
Invisible ink was used in the 1800s. It was invented by Pliny the Elder. They invented it to have a secret language.
You put a secret message by using the paper and you put heat below it so the ink is visible, or you can use a black light.
We wrote the message using invisible ink. Here's the black light shining on it. That's the message Bonner brings.
We researched the book dictionary cipher. The first number means the page. The second number means the column 1 or column 2. The third number means how many rows down it is. And the last number means how many letters over.
All right, so I'll give you a quick show of how it works. So 87 is the page number. Let me find it real quick. All right, then the first column, 12 rows down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then 7 letters over, 1, 2, 3, 4, 5, 6, 7. So B is the first one. Now I'll show you one more, then I'll just give you what it actually means. All right, 17. First column, 5, 1, 2, 3, 4, 5. Then 2 letters over, 1, 2. It's an O. So what this whole thing stands for is BONNER, Bonner Braves.
So right now we are doing the date shift cipher. For my example, April 4th, 2016. My key is 04416. So I'm decoding Bonner Braves. You would write your key over and over again over Bonner Braves. And the first time you do it, it goes forward that many letters, which of course you would end up getting this. And this is what somebody would receive. And then when the person receives it, they would put it here, and they would also receive the key. And then they do that exact same thing, except they go backwards that many, and it goes back to Bonner Braves. And that is the date shift cipher. Okay, so this is the Jefferson cipher wheel, as you see on the bottom. So you write down your code, which will also be Bonner Braves, and you pick a different row to do it, as shown. And then you turn it and find that code. You look on each row again, and then you try to find Bonner Braves, and it should have the one you did.
The cipher wheel is 2 interlocking rings. You code a message by following a prompt. With shift ciphers, the outer ring represents the decoded message and the inner ring represents the encoded message. So line up the outer ring A with the inner ring I, and now you can encode or decode your message.
The Caesar cipher is named after Julius Caesar, who, according to superstitions, used it with a shift of 3 to protect military secrets. While Caesar was the first recorded use of this scheme, other substitution ciphers are known to have been used earlier. And also, this is a Caesar slide, which can be used to do any alphabetic shift code you want.
A general in ancient Sparta invented the skilly to hide his message. He carefully wrapped a narrow strip of animal hide around a staff that he usually carried with him. Then he wrote his message along the staff, turning the staff every time he needed to write a new line of his message. Like this. And then when you unwrap it, they cannot tell what it says.
Our other code was the Greek square cipher, also known as the polybus square cipher. It was used 2,500 years ago for military use. So to make the polybus square cipher, you make a 6x6 square, number the top layer 0 through 5, and do the same with the right side of the grid. Then put the letters of the alphabet in the square in alphabetical order. Then write the numbers, go first up, then over, and you write the numbers like this. You write the numbers first with the numbers across the top, and then the side. And I and J share a square because there are not 25 letters in the alphabet.
The railfin cipher was created by soldiers in the Civil War to send messages without being intercepted by enemy soldiers.
Here's our example. We use Bonner Braves for our example, and we have to write it in a zigzag dig form on graph paper. We have 3 rows, so we start with 3 right here, and then we read it off row by row. So Bonner Braves, encrypted in the railfin cipher, is BEAONRRVSNBE.
The Playfair was the first practical digraph substitution cipher. The scheme was invented in 1854 by Charles Wheatstone, but was named after Lord Playfair, who promoted the use of the cipher. The technique encrypted pairs of letters instead of using single letters as in the simple substitution cipher. It is a polyalphabetic cipher.
The main part of the Playfair cipher is the keyword. Well, there's 3 main parts: keyword, secret message, and board. We need a 5x5 word and a keyword. What is our keyword?
Cipher.
And what we're trying to encrypt is Bonner Brave. And as you can see, there's an X in between the ends. And that's because you cannot have 2 of the same letters by each other. And if it's at the beginning, if the same letter is at the beginning and the end, you also have to put an X at the end. And so there are 3 different rules. And I will use the rule for the rule 3 for the first one because since they're not in this, rule 1 is you use rule 1 if it's in the same column, rule 2 if it's in the same row, and rule 3 if it's in neither. So as you see for B and O, we have B here and O here. So since B is first, we'll take it to above O and read it R. And we take O under B, and it becomes S. Our encrypted message. And you do the same thing for decrypting, but usually the board will be blank. You have to figure out what the keyword is, and then you just do everything backwards.
Basic machine codes were developed to help the military and wars.
Machine codes can use items such as typewriters, keyboards, and telephones. These machines already have letters and numbers printed on them, so it makes a natural way to create codes.
We'll show you an example with this old-fashioned telephone dial. 2 in the middle is B, 6 closest to the
In the middle, N, then another one.
and then E in the middle is E. 3 in the middle is E. 7 in the middle is R. 2 in the middle is B. 7 in the middle is R. 2 closest
To the side.
to the side, to the front is A. 8 closest to the bottom is V. And 3 in the middle is E. And 7 closest to the side is S. And this code is translated to Bonner Braves.
The word grill was invented by Girolamo Cardano in 1550. He lived in Pavia, Italy, and invented it to send a secret message by encrypting a message into a piece of cardboard or paper. The Cardano grill was invented by Girolamo Cardano in 1550 in Pavia, Italy. Just like the word grill, it was invented to send secret messages that looked like regular text.
Both ciphers are rectangular pieces of cardboard or paper which have openings. They are used to transport secret messages.
They are good to use because they are a simple way to send secret messages. However, they can easily be translated.
The Twisted Path cipher uses a rectangular grid. This is an example of the coded message. To decode the message, we simply draw a grid to match the number of letters in each group. In this case, it's 3 by 5. To decode, start at the bottom right corner.
As you can see, it spells Bonner Braves. To encode the message, you just fill in your grid and then write the message, copying the letters starting in the bottom right corner. In this case, it is used as we used the plow method.
This is the dot cipher.
How it works is you go down, you find where you want to start, you put a dot. And then if you want to do the second one, you go a line down, you go over to the letter you want, you go down, you put a dot, and R spells out B O N N E R space, which is a blank, B R A V E S space R O C K S. And it spells out Bonner Braves Rock. And if you want to turn it into a line cipher, you connect every 2 dots like this. And then if you want to turn it into a zigzag cipher, connect all those lines.
This is a simple cipher, but it's hard to decode.
We will be sharing with you the substitution cipher in literature and history. Edgar Allan Poe used the substitution cipher with punctuation. Arthur Conan Doyle had Sherlock Holmes put his skills of deduction to work in The Adventure of the Dancing Men.
The substitution cipher was attributed to Charlemagne, who ruled in the 8th and 9th century. He relied on his substitution cipher when he communicated with his general. Note that there is no J, V, or W because those letters were not part of the alphabet back then. Mary, Queen of Scots, used a substitution cipher that was decoded because of the information found by her enemies in the messages, she was executed for trying to overthrow the queen.
Today I am presenting the space code. The space code is where you put spaces or periods anywhere. It is a great way to hide a secret code. Now I'll give you 5 seconds while I'm talking to solve this. Space code is ancient. Space code, for those who know it, is very easy. It will be easy to learn and catch on to. You can make an easy to figure out code really hard to figure out by just adding spaces and periods. I hope you learned a lot about the space code, and the answer is Bonner Braves.
Ready to decode the null cipher? The null cipher is the easiest way to hide a message. You can hide a message within a sentence or a group of words. You just have to know which letter in each word would be the secret. It would be the secret code. For example, beautiful owls never nap. Eagles rule. Birds ruin awesome violent exercises. I bet you guys are looking at that like I'm insane. But then if you really find out, in this case, that's just the beginning letter. It's just the beginning letter of each word. B, O, N, N, E, R, Bonner. Then we have B, R, A, V, E, S. Bonner Braves. In this case, we're doing the beginning of the letter, but it can be any letter. It could be the third letter, it could be the fourth letter. You can even skip 2 words and do the beginning of the next letter. You can do it any case, but this case, I just did the beginning letter. Thanks